Well, Algebra 3, this is our lesson 7.5 in compound interest. That is an exponential growth function, compound interest. So just briefly explain to you what compound interest is. When you put money in the bank, you earn interest. And when they compound the interest, say they do it quarterly or semi-annually, either way, however often they do it, you start earning interest on the interest. And then you start earning interest on that interest on that interest. And it compounds the growth rate. So it's an exponential function. Because we're compounding, however, this is a little more of a involved calculation than just exponential growth. So here is the formula for compound interest. This is going to be our final amount, A here. But what are these amounts? What are these amounts? Principal, that's our principal amount. And what does the principal amount mean? Well, that's just our initial amount. That's what our principal means. Okay, our next variable on there is R, and that's just going to be our rate. So that is our rate of growth, and that's usually expressed in an annual percentage. N is the number of times it compounds yearly. Okay, so the number of times it compounds yearly. So we need to think about that. If it's compounding semi-annually, it's compounding twice. If it's compounding quarterly, it compounds 4 times. And finally, T, well, you guessed it, that is time. So I want to pause this and jot this down. This is our formula we're going to use to calculate compound interest. So we'll go through a couple examples here. We'll get started here with example 1. Here is example 1 in dealing with compound interest. Laura deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? All right, so let's figure out our P, our R, and our T. Our principal is our initial amount. We're told here that that's $12,000. Our rate, well, what rate are we growing at? We're growing at 8%. Number of times compounded per year. It's compounded quarterly. How many quarters do we have in a year? 4. And we are looking for the amount we're going to have in 5 years. Okay, so our initial amount, our principal is $12,000. Our rate, which is R, that's 8%. Number of times compounded per year, quarterly. There's 4 quarters in a year, so it's going to compound 4 times. And we're looking for the amount we're going to have in 5 years. All right, so let's plug these numbers into our formula here. So we'll have our amount is going to equal our principal of $12,000 times 1 plus our rate of 8. That's 0.08 over 5. Over 4, number of quarters, 4. And we're going to raise that to the number of times compounded of 4 times the number of years, so that's 4 times 5. So we plugged in our initial amount here. We've got our rate, which I should have written in decimal form here. 8% is 0.08. So we're going to have 0.08, our rate, over our number of times we compound, N of 4. We're raising that to the N times T, or 4 times 5. Let's simplify this up a little bit. A equals 12,000. Let's just simplify what we got going on inside the parentheses here. So we're going to have 0.08 divided by 4. That's 0.02. So we're going to have 1.02 inside the parentheses. And of course, 4 times 5 is 20. So now we just need to, let's raise 1.02 to the 20 power. And that's 1.4859. We're going to multiply that by 12,000. And our amount will be $17,831.37. So after 5 years of compounding quarterly, we get $17,831.37. Here's example 2. Jack took out a 6-year loan for $25,000 to buy a boat at a rate of 4.5%. At a 4.5% interest rate. If the interest is compounded monthly, what will he have paid total over the course of the loan? So let's find our P, our R, our N, and our T. Our initial amount tells us right here is $25,000. Our rate, our interest rate is 4.5%. 4.5%. Let's write that as a decimal, so that's 0.045. The number of times it compounds a year, it compounds monthly. There's 12 months in a year, so we'll have 12 compounds. And our time, what was the time frame? It was a 6-year loan, so our T will equal 6. So to figure out the total that he paid over the course of the loan, we're going to figure out the total amount. That's what our A is, our total amount. So we will have A equals our principal amount of $25,000. We're going to multiply that times 1 plus our rate of 0.045 over our N. N is 12. And we're going to raise that to the N times T, or the 12 times 6. Okay, so let's kind of simplify what we going on in the parentheses there. So we'll have our total equals 25,000, and we have 0.045 divided by 12 plus 1 is going to give us 1.00375 inside the parentheses. We're going to raise that to the 72nd power. So when we raise that to the 72nd power, we get 1.309, and we're going to multiply that by 25,000. And that gives us a total amount of $32,732.58. Turned out to be kind of an expensive boat there. $32,732.58 is the total amount that Jack spent over the course of the 6-year loan. Let's take a look at one more example here. Example 3, a savings account offers 0.8% interest compounded semi-monthly. If Bob deposited $300 into this account, how much interest will he earn after 10 years? Well, this is an interesting question in that it's not asking us to find the amount after 10 years. It's asking us to find how much interest he got after 10 years. So what is interest? That's going to be the amount that he earned over his principal. So we're still going to calculate the amount, the total amount after 10 years. We're going to take that amount and subtract our initial principal of $300, and that's going to give us what he earned over that 10-year period. So let's identify our P, our R, our N, and our T. Our principal, our starting amount is $300. Our rate is 0.8%, or if we write that as a decimal, 0.008. The number of times that we compound each year will be, let's see, what do we say, semi-monthly. So that's to be twice a month, so that'll be 24 compounds during the year. And we're looking for 10 years. Okay, so let's plug these numbers into our formula. So we're going to get our total amount is going to equal our principal of 300 times 1 plus, we're going to have our rate 0.008 over our number of times that we compound, that's 24. And we're going to raise that to the 24 times 10 power. And that's going to give us our total amount. So let's simplify what we got going on inside the parentheses here first. So 0.008 divided by 24. We're going to add that to 1. And that's going to give us 1.00033 on the inside. And we're going to raise that to the 240th power. So let me go ahead and raise that to the 240th power. And I get 1.083 after I do this calculation here. So I'm going to multiply that 1.083 times 300. And I will get, for my total amount after 10 years, I get $324.98. But that's not what the question asked us. It asked us how much interest will he earn. So if we started off with $300 and we ended with $324.98, how much did we earn? We earned $24.98 interest after 10 years. So we got to be careful. We got to make sure we read these problems and answer exactly what they're asking for. We just want to know how much interest here and not what the total amount was. So hopefully working through those 3 examples on compound interest, you understand how to use this formula. So if you have any questions, email me. Otherwise, go do your homework.